omega 1, omega 2, and omega 3 each have radius 4 and are placed in the plane so that each circle is externally tangent to the other two. Points P1, P2, and P3 lie on omega 1, omega 2, and omega 3 respectively, such that P1, P2 equals P2, P3 equals P3, P1, and line PI, PI plus 1 is tangent to omega I for I equals 1, 2, and 3, where P4 equals P1. The area of P1, P2, P3 can be written in the form the square root of A plus the square root of B for positive integers A and B. What is A plus B? So we have three circles, omega 1, omega 2, and omega 3, and then we choose points P1, P2, and P3 on those three circles in such a way that triangle P1, P2, P3 is equilateral, but also line P1, P2 is tangent to omega 1, and line P2, P3 is tangent to omega 2, line P3, P1 is also tangent to omega 3. Now, because of the symmetry of this, the tangency applies everywhere, and the triangle is equilateral. The center of this triangle is going to be located at the exact same place as the center of this diagram consisting of the three circles. And what I mean by that is the center of the triangle that's formed by connecting the centers of the three circles, which obviously is also equilateral because all three circles have the same radius, 4. So I will call the centers of those circles O1, O2, and O3. O1 is the center of omega 1, and define O2 and O3 similarly. I will denote the center of both triangle O1, O2, O3 and triangle P1, P2, P3 as C. So now, what interesting stuff can we learn? Well, first off, we know that angle O1, P1, P2 is a right angle because P1, P2 is tangent to omega 1. So it's always going to form a right angle with the center. Note also that angle CP1, P2, which is this angle, is going to be equal to half angle P2, P1, P3, because it's the center of an equilateral triangle. So we have angle P2, P1C equals 1/2 of angle P2, P1, P3, which is just 1/2 of 60, and that's 30. So we can get angle O1, P1C is equal to angle O1, P1, P2, which is 90, minus angle P2, P1C, which is 30, and that's equal to 60. So it turns out that this angle here is equal to 60. Let's connect O1 and C back, like that. Now, we also know some other stuff about triangle O1, P1C. We know two of its sides. The first one is obvious. O1, P1 is just the radius of omega 1, which is 4. And O1C, well, O1C is just the distance from O1 to the center of equilateral triangle O1, O2, O3, which has side length 4 plus 4, and that's equal to 8. So the distance from a vertex to the center is always going to be equal to side length over root 3. So in this case, that's 8 over root 3. And we can do the same thing for P1C. If its side length is x for triangle P1, P2, P3, then the distance from P1 or P2 or P3 to the center in the equilateral triangle, if it has side length x, it's going to be x over root 3. So now we're ready to break out the law of cosines where the 60-degree angle is located at O1, P1C. So we have O1, P1 squared, which is 4 squared, plus P1C squared, which is x over root 3 squared. If it's a 60-degree angle, we just do a squared plus b squared minus ab equals c squared. So minus 4x over root 3 is equal to 8 over root 3 squared, O1c squared. And that's equal to 64 over 3. Now we can multiply this entire equation by 3 to get that 4 squared times 3, which is 48, plus x squared over 3 times 3, which is just x squared, minus 4 root 3x equals 64. So x squared minus 4 root 3x plus 48 is equal to 64. And therefore, we have x squared minus 4 root 3x minus 16. If we subtract 64 from both sides, that's going to be equal to 0. So now we can use the quadratic formula to determine the value of x. We have x equals minus b, which is 4 root 3, plus or minus the square root of b squared, which is 4 root 3 squared. That's 48. Minus 4ac, which is just minus 4 times minus 16. And that's plus 64. All of that over 2a, which is just 2. So this is equal to 2 root 3 plus or minus the square root of 112 over 2. And that's equal to 2 root 3 plus or minus the square root of 112 is 4 root 7. So if we divide 4 root 7 by 2, we get plus or minus 2 root 7. And that's equal to x, which is the side length of triangle P1, P2, P3. Now obviously we can't have the side length be negative, so it can't be 2 root 3 minus 2 root 7, which is negative since 2 root 7 is clearly greater than 2 root 3. So we have to take the positive solution, x equals 2 root 3 plus 2 root 7. I will use that when we do our computation for the area of triangle P1, P2, P3, which is x squared root 3 over 4. So that's just 2 root 3 plus 2 root 7 squared times root 3 over 4. Now, 2 root 3 plus 2 root 7 squared over 4 is just root 3 plus root 7 squared. So all we're really looking for is root 3 times root 3 plus root 7 squared. And that is equal to root 3 times 3 plus 7, which is 10, plus 2 times root 3 times root 7, which is 2 root 21. So this is equal to 10 root 3 plus 2 root 21 times 3, which is 2 root 63. The area of triangle P1, P2, P3 is 10 root 3 plus 2 root 63. And we want it to be written in the form the square root of a plus the square root of b for positive integers a and b. So it's the square root of 3 times 10 squared plus the square root of 63 times 2 squared. 3 times 100 is 300. And 63 times 4 is 252. So a is 300 and b is 252, or vice versa. What is a plus b? That's just 300 plus 252, which is equal to d, 552. So thank you all for watching my YouTube video. I hope you enjoyed, and please follow my channel if you would like to see more videos.